Hello everyone, my name is Aarohi and welcome back to my channel. So guys, before we begin today's lecture, I want to say huge thank you to all of you. I asked for your support in the last video and you all really supported me. Your likes and comments made me so happy. Thank you so much for that. And guys, please show the same kind of support for this video too. Now let's start today's lecture. So in our last lecture, we built our own LLM from scratch. And today we will work on the same code, but we will improve it. Majorly, we will focus on tokenization libraries. So we will learn how to use tokenizers like BPE and SentencePiece. After that, I'll show you how to use pre-trained tokenizers, and then we will see how to train our own tokenizer. And guys, we will use the same dataset which we used in our last lecture, these 10 lines, and our LLM code will also remain same. So if you remember, we wrote the code for TinyGPT class. Okay, let me open that code. So this is what we did in last class. Remember, this is the data set. These 10 lines, we are going to use the same data set today. And then we used these lines. These are the data pre-processing steps which we have performed. And today we will replace this code with the tokenizer. In our last class, we performed tokenization using this. And then we got the vocabulary size of the LLM using this line. Then after getting the tokens out of the text of our dataset, we provided the unique ID to each token, right? And then we created the 1D tensor of those tokens so that we can have a 1D tensor for our dataset. So after that, we created this code, TinyGPT class, and we learned everything about this class. I explained you this code step by step. So this TinyGPT class, which is our LLM, which we built from scratch, this class will remain same. This get batch function will remain same. And how to train our model, this will also remain same. The only change which we are going to do today is this part, okay? The data pre-processing step, which means that we are not going to do the tokenization with the help of Python code, which we have used in the last class. We will replace this with the actual tokenizer, because in real LLMs, we don't write Python code like this for the tokenization step. We use tokenization libraries. And that is what we are going to study today. And guys, this lecture is built upon the previous lecture. I will explain everything here, but if something is unclear, please check the last video, because that video will clear all your doubts, because I have explained everything over there step by step. So let's start today's work. So to run today's code, you need PyTorch. You can install PyTorch like this. Just write here, install PyTorch, enter. You will be redirected to this kind of page. And from here, just pick this first link and scroll down. You will come under this section, install Torch. Pick the Torch version. The recent stable version is 2.9.1. And from here, you will pick the operating system. Mine is Windows, so I have selected Windows. We want to use pip package manager to install this PyTorch. Then we are working on Python, so we will select this. And then here, CUDA versions are mentioned. Now, from here, if you are using a laptop or a computer which have GPU, then you will check your PC that which CUDA version is there in your PC. And as per that CUDA version, you will pick the right command from here to install the PyTorch. So let's say if in your PC you have CUDA 12.8, then you will click on this and you will get a command which will install the PyTorch compiled with CUDA 12.8. And if you have CUDA 13, you will click here and you will get the command according to that CUDA version. And let's say if you are using a PC or a machine which doesn't have any GPU, then you will select the CPU and you will install PyTorch like this. Okay. And guys, let's say if you're not working on your PC, you're working on a Google Colab notebook, then over there also the same code will work. You just need to select the GPU from the notebook setting of the Google Colab, and you will install the PyTorch like this only, the commands which are mentioned here, the commands which I'm showing you over here. And the same code which will work on your local machine, the same code you will paste on your Google Colab notebook and it will work there also. So once you install PyTorch, you can run today's code which I'm going to show you. So let me open my VS Code where we are going to work today. So here we are going to work, and guys, let me open the folder where we are going to work today. So the folder is this. So in my last class, we worked in this folder, right? Today, we are going to work in this folder, lecture 3, TinyGPT, and we are adding tokenizer in it. So just select this folder. And right now we are in this folder and there is nothing in this folder. So we are going to write everything. Before that, let's open our terminal. So we are in this folder right now. Do cd dot dot and this. So now we are in LLM tutorials folder. So guys, here I have created a separate environment. So I'm going to work under it. So separate environment simply means that I have installed a separate Python for this tutorial and I will work under it. So this is always a best practice to work under a separate environment, because sometimes if you mess up with your environment while working with the code, then the other codes will also stop working. So it is always a best practice to work under a separate environment. So if you mess up anything in your current environment, then rest of the codes which you have in your PC will not be affected by this change. My environment is this. This is the environment name, myvenv scripts and activate. This is how you activate the environment in Windows. Now our environment is activated. We can go in the folder, we can enter in the folder where we are going to work today. So it is in module 0, and in module 0 I have a folder with the name of lecture 3 TinyGPT adding tokenizer. Here we are going to work today. Now let's create one file over here in this folder. So just click here and give the file name. So let's say I am giving the name TinyGPT underscore tokenizer.py. So this is my file where I'm going to work. Now, the first thing is that we will copy the same code which we have done in the last class. First step is this. So let's do that. So this is that code. Let me show you the entire code. So this is the code which we used in our last class, and this is the data set, and these are the steps which we have performed on it, and then we got this data. Okay, let me just print the output of this lecture once, this code once. Okay, so no module name transformer blocks. So guys, remember in our last class, we created one separate file with the name of transformer blocks.py, and there we have one class with the name of block. So that file is currently not present in this TinyGPT folder. So that's why we got this error. Now let's paste that transformer blocks.py file in a TinyGPT folder only, then this code will work. So for that, let me open a folder. So this is our folder. See, here we are working now in this folder. So let's paste that file over here. And now let's open the VS Code again and rerun this code. See, now you can see the output. This was the first step which we did. And then we divided it into tokens like this. Then we provided one unique number to each token. Then at the final step in data, we created the 1D tensor and we arranged our data like this. Okay, so this is what we did. This part is done by the tokenizer in real LLMs, but in previous class we did it with the Python. So we are going to replace this code with the actual tokenizer now. So let me show you how to do that. So you will, first thing is, we are not going to have our dataset over here. We will create a separate file with the name of corpus.txt, and in that we are going to paste this dataset. Okay, so now I'm commenting this part from here because we are going to have a separate file with the name of corpus.txt. In that file, we are going to paste this code. So let's do that step first. So here, this is my corpus.txt file in this folder only, and let's open it and see it. Okay, it is over here. See, so these are the 10 sentences, right? So we have all those sentences over here, one sentence in one line, and this is my data set now. Now the next step is this. Now we are going to comment all these things, this part, this, and all this part till here. Why? Because this is a Python script which performed the tokenization in our last tutorial, but today we are going to use the actual tokenizer. So we commented this part of the code, and we are going to install the tokenization library now, and then we will use that tokenization library to perform this task. So let's do that. But before installing, let me tell you that there are different options for tokenizers. So if you want to use SentencePiece tokenizer, then you will install this SentencePiece tokenizer by writing pip install SentencePiece. And if you want to use BPE tokenizer, then you will run pip install tokenizers. This will give you BPE trainer, it will give you BPE tokenizer, encoding and decoding function, right? Like this. And if you want to load a pre-trained embedding model like Word2Vec or FastText, then you will write pip install gensim, GENSIM. And if you want to use Hugging Face embedding model, then you will run pip install transformers. So these are the different ways to use tokenizers. And today we will see all of them. So first, let's start with the SentencePiece tokenizer. So we will run pip install SentencePiece, and SentencePiece tokenizer will be installed. You can see in this screenshot, I have already performed this step. You just need to write pip install SentencePiece, and you have this tokenizer installed now. And guys, when we are building our LLM from scratch, so tokenizer choice matters a lot. So we have two options. Option one is that we can train our own tokenizer, and we can train it on our own dataset. Okay, own tokenizer simply means that we will give our own dataset and we will train that tokenizer on that dataset. Okay. And the second option is we can use the pre-trained tokenizers, like the tokenizers like GPT-2, LLaMA, BERT, T5, or any other pre-trained tokenizer. And pre-trained tokenizer simply means the tokenizer that has already been created and trained along with a model like GPT-2, BERT, LLaMA, T5, or other LLMs. And while choosing this pre-trained tokenizer, always remember that each model was trained with its own specific way of splitting text into tokens. Okay. Suppose, for example, GPT-2 might split unbelievable word as a in three tokens, like un as one token, believe as one token, and able as one token. And BERT might split it differently. It might split it in two tokens, like un as one token and believable as another token. Okay. So tokenization libraries and or pre-trained tokenizers. Let's talk about pre-trained tokenizer. Pre-trained tokenizers will not always give you same kind of token. Okay. Every pre-trained tokenization method, if you are using pre-trained tokenizer, if you are using, they might split the words into different set of tokens. All right. Now let's see what is the difference between these two and which option is best for us in our scenario. Like we are creating the LLM from scratch. So which option is best for us? You creating our own tokenizer or using a pre-trained tokenizer? Okay. So first question is, why should we train our own tokenizer? Right. So there are two options of tokenizer, and let's say if we decide to go with, let's train our own tokenizer on our own dataset. But then there is a question that why should we use our own tokenizer? Why should we train our own tokenizer if there are already available tokenizers are there, pre-trained tokenizers are there? Because your dataset is different from GPT's dataset, BERT dataset, LLaMA's dataset, or any other LLM's dataset. So for example, let's say you want to build a domain specific LLM, like LLM which specifically is designed for medical queries or legal queries. Or let's say you want to build an LLM which can reply with Hindi English mixed responses. And if your dataset contains Indian city names or Hindi English mixed sentences, words, festivals of India, local slangs, or local foods, if your dataset have these kind of words, then if you decide to use the pre-trained tokenizer in this scenario, then it will not be a good choice. Why? Because pre-trained tokenizers don't know these words well. Okay, so for example, we have a sentence, I love samosa. Now, a pre-trained English tokenizer might break this samosa badly. So, for example, let's say GPT tokenizer divided this samosa word in three tokens, like sa as one token, mos as one token, a as one token. So, it that pre-trained tokenizer broken it very badly. This is a bad split, right? So, this will create a problem of too many unknown tokens, right? But if you use your own tokenizer, the tokenizer which you trained on your dataset, then it will be it can give you a perfect token, like samosa as one token, no meaning loss, right? Why? Because we are training our own tokenizer on our own custom dataset, which is Hindi English mixed sentences, and that way we can get perfect tokens because we trained the tokenizer on our own dataset and it learned properly. So, when to train our own tokenizer? When you know that LLM which you are going to create is going to be trained on a unique dataset, and that kind of vocabulary it is not going to have in a regular pre-trained tokenizer, then train your own tokenizer. But when you are creating a LLM which is just going to have a general English, then use pre-trained tokenizer, because then it will not create lot of weird tokens for uncommon words. So what I'm trying to say over here is that a tokenizer which is trained on your dataset will learn your vocabulary, your spelling pattern, and your style of writing. So today, first we will see how to train our own tokenizer on our raw data. So let me explain you this clearly, slowly, and step by step so that you fully understand what is happening here. So guys, why do we need tokenizer? Because when you are creating a new LLM from scratch, your raw data set is just text. So, for example, hello, my name is Aarohi, I love coding. This is a raw text, but a neural network cannot understand text. So, before the model can learn anything, you must convert this text into tokens and tokens into numbers. And for this, we use tokenizers. And today, now I'm going to show you how to use a tokenizer. So, we have installed the SentencePiece tokenizer. Now, let's use it. So, we have commented this part, and now I am going to first import the tokenizer SentencePiece, and this is how you're going to import it. We are importing the SentencePiece at SPM. Now what we want to read our dataset. This dataset we want to read. Why? Because we want to create the tokenizer on our dataset. We are going to train this SentencePiece algorithm on our dataset, that how to generate tokens. So let's write the code which will load this corpus.txt file and read the text from it. So you will write this for this, open corpus.txt, and in text variable we are reading that file. Which file? Corpus.txt file. Now let's write a code which will train the SentencePiece tokenizer on our dataset, which is corpus.txt. So this is the code for that. SPM this dot train will train it. We want to train it on this dataset, which is our custom dataset, 10 lines, and model prefix is tokenizer. So this will when we will save this tokenizer, at the time we are going to use this name as a file name. Vocab size is 40. So guys, if you remember from our last class, we used this dataset and we got the vocabulary size 42. Okay, so over here I've written 40 as per that, because our dataset is very small. You cannot write 200 over here or 300 over here, because then you will get an error, because our dataset is too small to create the vocabulary of 200 different words. So as per your dataset, you choose the vocabulary size. So here my vocabulary size is 40 because I have only 10 sentences, and model type is BPE. So when you will run this code, after running this code, what will happen? You will have two files in your current folder. One file will be your trained tokenizer model, and another file will be the list of tokens which are created on the basis of your dataset. And once you train the model, once you train the model, you will load it like this. See, when you want to use the this tokenizer, you will use SentencePiece processor. When you want to train it, you will use train, and we are loading the model. So what I've told you, that this model prefix, when you'll execute this code, you will get a file with the name of, you will get two files. First file will be tokenizer dot model. This is your trained model. Okay, so this is your trained model, and we will load it to perform the tokenization. And then you will have one more file with the name of tokenizer.vocab. Here you are going to have tokens. You can see these, you can open this file and you can see it. Okay, after this step you will get these two files, and now you have tokenizer.model. Then you are loading it. Okay, so this is how you load the tokenizer. Once you load the tokenizer, now we can perform tokenization using it. So what we will do, we will get all the text which is there in text variable. What is there in text variable? The data from the corpus.txt. So we will provide this text variable to this tokenizer, and we want to give unique IDs to each word. So this is what tokenizer does. Tokenizer does two tasks, right? First, it split the text into tokens, and then it provide unique number to each token, the vocabulary. So that part we are going to do now. This is what you can do. This will, in IDs variable, I'm using sp.encode. We want to encode the entire text. The output which you'll get here, that output will be a list in the form of list, and this list will not be accepted by the LLM. We need to convert this list into a tensor, then only your LLM will accept this data. So for that you will write this code, torch.tensor. This is how you convert your data into tensors. We are providing this IDs variable to it, and it will create a tensor. Now you can print it and see if you are getting IDs for the words which are there in our file. Okay, so just print data, save it, and here run it. So we are getting this error. So first, why we are getting this error? Because we need to modify our code as per this tokenizer, and this is the output which we want to see right now. We got the unique ID for each token which is there in our dataset corpus.txt. So earlier in last class, how we performed this task? We performed this task using this, and now we replaced it with this code. And now let's check the vocabulary size. So for that, I'm using the same variable vocab size this we used in the last class, and this is how you can get the vocabulary size. Okay, let's print it. Print the vocab size. Okay, save it, and let's run it. So we are running the file again. See, the vocabulary size is 40. Why the vocabulary size is 40? So guys, remember, in our SentencePiece trainer, we have mentioned that we want the vocabulary size to be 40. So that's why we are getting the vocab size as 40. After that, we have this part. And guys, this part you already know, because if you have gone through the previous lecture, over there I have explained in detail what these parameters are. If you don't know what these parameters are, please check that video. That will clear all your doubt. Okay, so I'm just giving you a brief idea. This block size is context window, context size, which is 6 in this case because our data set is very small, and context length simply means how many previous tokens your LLM will see to generate the next word. And the main goal of the LLM is how LLM work. LLM generate one word at a time. They predict one word at a time, next token based on the previous tokens, and those previous tokens are called context size, and we are using the block size variable for that, and our block size is 6. That means the LLM which we are going to create, that LLM will see the previous 6 tokens and it will generate the next token. And then we use the embedding dimension 32. This embedding dimension is this we will use while training our TinyGPT model. This because your LLM will not understand the data in this format. Okay, right now what we got in this data variable. The data variable, okay, wait. This data variable, what we have here, we have data like this. 1D tensor, like we have some number 45, 67, 98, 12, something like this. We have these kind of unique numbers, but your LLM will not understand these numbers. You need to convert each of this number, which represents one token, into a 1D vector, and every vector, each vector will have 32 floating point values in it, and initially those 32 floating point values will be random, but with training your model will learn those values, and then the words which are similar to each other, those words will have a similar kind of 1D vector. Okay, so if you want to understand this in detail, check the previous lecture please. Then this n heads means how many multi-head attention layers you want to have in a transformer, because guys, all modern LLMs are built using which architecture? Transformers architecture. Today we are not going to understand that architecture in detail, we will do that in next video. Just understand that in transformer architecture we have different kind of layers, multi-head attention layer, transformer blocks. So we are defining those layers over here. N head 2 means we want two self attention layers, and then n underscore layers 2 means we want two transformer blocks stacked one after the other. First transformer layer, the output of that will go to the second transformer layer, and the learning rate we are using is this epochs is 1500. And then we have a get batch function. This part also I explained in detail in last video. The batch size 16 simply means we will give 16 examples, 16 sequences in one batch to the model, and this line will fetch the 16 random index IDs, and from those 16 random index IDs we will pick the 16 sequences, and we will arrange the data which we are going to give to our LLM. We will give that data in a pair, means for every x value we are going to have a y value. So we are preparing the x and y for that batch. So if x have 6 tokens in one sequence, then y will also have 6 tokens in one sequence. One sequence means the one sentence which we will give to the model. Okay, so if the last token of x is 13, let's say the last token, if the last token of x is 13, then the last token of y will be 14. Okay, why? Because LLMs, they predict next word, they generate next word, one word at a time. And if x, the last token of x is 13, token number 13, then the y, okay, wait. Then the last token of y will be 14. Okay, one next word. Okay, if you want to understand this function in detail, then please check the last video. After that, we created the TinyGPT model, and there we are using the embedding model, because in transformer, how transformer worked, to give data to the transformer you need to perform some steps on it, and I have told you here embedding dimension. So guys, embedding dimension simply means for each token you are going to have a 1D vector which will have 32 values. So that is what we are doing over here. So basically in this step, this embedding layer, what it does is, this is basically a embedding model only, and we are telling that embedding model that our vocab size is 40. We have mentioned this 40 above, right? So we are telling our embedding layer that the vocabulary size is 40. Here, let me write that the vocabulary size is 40 and the embedding size is 32, because we have mentioned the embedding size over here. So it will create 40, it will create 40 32 dimensionals 1D vector, one 1D vector for each word. So we will have a matrix over here. At this step, what will happen? We'll have a matrix over here, and that matrix will have how many rows? 40 rows. Okay. Why 40 rows? Because the vocabulary size is 40. And each row will have how many values? 32 values. Okay. 32 floating point values will have. And these 32 values initially will be random. And this embedding layer itself will provide the random values to it. And then when you'll train your model, those values will be learned. And the words, let's say words, sweets and taste are there in our vocabulary, then these words will have similar kind of embeddings, because these words, there is some relationship between these words. Okay, like this. And then we have a position embedding layer. Position embedding layer simply tell the position of each word in a sentence. So when we speak, so there is a position of words. So for example, I'm saying hello friends, how are you? So every word have a position, means which word is coming first, and then after that which word is next, and after that which word is coming. So every word has a position. And if you will not tell the position of the words to the model, then model will not understand the meaning of the sentence, right? And that's why we need to send the positions also. That's what we are doing over here. So guys, over here also the dimension will be block sizes 6, because we are going to have 6 tokens in each 6 token in each sequence, and the embedding dimension is 32. And again guys, I am not explaining all these things in detail. Please check the last video, there you will understand everything. And then we are using a block class. This block class we are getting from which file? We are getting from transformer blocks file. And what is there in the transformer block file? Remember, we have written the code for transformer layers, which we are not understanding today. We will cover it in next topic, next video. And after that, this is our final layer. This layer will give the output, and then we have a forward function in TinyGPT class only. This forward function will work on one batch at a time. And you can see here that first the batch will come here. So for example, there are 6. So B means batch size. So how many images we have? How many sentences we have in one batch? 16, right? And T stands here for this the context length. So context length is 16. So in B we have 16, in T we have 6. Then we have a token embedding layer. These 16 examples are going to the token embedding. Then those 16 examples, on those 16 examples we want to perform the position embedding also. Then to create the X, to create the input, we are concatenating the token embedding with the position embedding. Means with each token we are adding the position to it. Now our input is ready to give to the transformer. Here we are using the transformer will work on it. Then this will be our in logits we are going to have a final output. Final output simply means the next word prediction which our model will predict. So logits store the raw predictions. Means we have 40 words in our vocabulary. So that means each of that token will have one probability value, and the word which will have high probability value will become the next word. And then this we are using to store the loss. This is right now it is none. And after these steps we are filling value in it. We will save the loss in it. And what we are doing is, see, logits dot shape, what we are going to have in logits. Okay, let's discuss this part. What is B? Batch size, which is 16. T, I have told you context length, which is block size, and the value is 6 we have defined above. C simply means our vocabulary size. So in our case, what is our vocabulary? We have defined above that the vocabulary is 40. Logits.shape means that for every batch in which we are going to have the batch where we are going to have 16 example, each example have 16 tokens in it. For those tokens we are going to have 40 values, and the 40 means the vocabulary, means all those 40 words which are there in vocabulary. For every word we are going to have a probability value, and we are using a cross entropy loss function. Using this cross entropy loss function, we will see the word which are model predicted and the actual y which we are getting from this get batch function. For every sequence, we have prepared one y value, right? And the y value will always be one token next to the x token. So we will compare this y with the y which model predicted, and on the basis of that we are calculating the loss function. Then we have a generate function in TinyGPT class. This generate function is used to generate the next token. Let's see here, this max new tokens. So guys, as I've told you in the last class also, max new token simply tells how many new tokens you want to generate. So let's say you gave one input sequence to the model and you want that your model should generate the next 15 words or 20 words. So that number you will provide over here. Then, so guys, remember, model will generate one token at a time. But if you provide max new token 15 over here, then this loop will work for 15 times, and every time it will generate one word. Okay. So for example, the input sequence which you gave to your model is hello friends. This is, let's say, this is the input which you gave to your model, and you want that your model should generate 15 next words. Okay, you want that your model should generate 15 next words. Then what will happen? This hello friends will become input to this generate function. Then your model will, here logits, what I've told you, what are logits? Logits are raw predictions. That logits will give a probability value to each of the vocabulary words, which is 40, and the word which will have high probability will become the next word. Okay, so we will get the one word. Then we are applying the softmax activation function on those predictions. Softmax activation function will give you the probability scores between 0 to 1, and then the one word which is going to have a highest probability from this probs variable. We are fetching the one token which is having the highest probability. That token we are choosing as a next token. So let's say your model gave after hello friends how as the how token which have the highest probability as a next token, then that will become the next token, and then that next token we are adding to our input sequence using this. Means now our input sequence will become how hello friends how are how, because how is generated. Then this will become input over here. Then again the same process will be followed. So this is how your model generate the output. And once you create your model, TinyGPT model, now is the time to train your model. And to train your model, first in model variable I am writing this TinyGPT over here. But right now this model is not trained on anything. We have just defined, we wrote the code, but this model cannot do anything right now because it is not trained on any data set yet. So we want to train it. So for that we need one optimizer also. We are using the optimizer. To this optimizer we are providing our TinyGPT model, and then learning rate we have defined above. So in this loop we are training the model for 1500 epochs, and we are getting the data in batches using the get batch function. This we have defined above. We got the x and the y. We trained the model. We calculated the logits. Logits are raw predictions. And once you calculate the loss, we are clearing the gradients from the previous epoch using this. Then wherever you train the model, there are two passes, forward pass and backward pass. In forward pass you train the model, which we have done over here. Now in the backward pass we will update the weights, we will see the loss, and then using optimizer we will update the weights, right? That is what we are doing. And after every 300 steps we are showing the loss on the screen. So when you run this code, your model will be trained. After that you need to test the model. So let's give some input sequence to the model and let's see how model generates the output. Okay, so in our previous class we wrote this, but today we are not going to use this. Let's just comment this part. Let's just comment all of this and write the code. So see what I'm doing. This is what first I'm loading the SentencePiece tokenizer. remember we have saved the tokenizer with this name. Then to this tokenizer, we are giving hello as a context, as an input. We are giving one word to it. And we want to use the generate function of the model. Remember here, generate function of the model. Which model? TinyGPT model. And we have this TinyGPT model in this variable, right? That is what we are doing. So hello word we are giving to the model, and model will generate how many tokens? 20 next tokens. And then let's print it. To get the output, you will write this, right? See, first we used sp.encode. What it is? So hello word which user wrote, that word will be converted into the token, because then into some ID, because then only your model will understand that word. Then it will work on it. Model will work on it. Once it will perform the work, after that we are decoding it, because now we don't understand the numbers, we need the data in English back. So that's why we are using a decode function. So this encode and decode function are the functions in your tokenizer. In using encode function, we convert the tokens, which are words, into numbers, and using the decode function, we get the words back from the numbers. Okay, so let's save it and run it. See, training has started. Hello friends, how are you? This is, see, hello is the input to it, and we created model generated this after that. And if you'll go here, see tokenizer.model. Remember, I've told you when you'll run that code, you will get a tokenizer.model file and you will get a tokenizer.vocab file. So we got these two files. This is our data set, and this file shows the code which I'm showing you, and this is the transformer layers which we are using. We haven't discussed the code of this file because we will understand it once we understand the concept of transformer. So guys, this is how you can create LLM from scratch using tokenizers. And I hope this video is helpful. And guys, the link of this code is given in description section. And if you like my content, please like, share and subscribe my channel. Thank you for watching.